Okay, now as we know the principle of homogeneity of dimensions, like the dimensions on MLT on either side of relation must be same. Okay, so basically we have to obey this principle of homogeneity of dimension. Now you should know that further quantities added together must have the same dimensions, and the quantities subtracted from one another must have the same dimension. This we will illustrate by an example. Now, so this is our example. In a van der Waals equation, this is a van der Waals equation. This is P plus A by V square, V minus B equals RT. This is P plus A by V square into V minus B, that is equals to R into T. What are the dimensions of A and B? You have to find the dimension of A and B. Here P is pressure, V is volume of gas, T is temperature, and R is gas constant. So this is our given equation. So this is the equation, which is P plus A by V square, V minus B equals RT. As you know, I have told you that the quantities added together must have same dimension, and the quantities subtracted from one another must also have the same dimension. Okay. Now we know pressure can be added to pressure only. To pressure, therefore, the pressure can be added to pressure. Therefore, A by V square. What did see? Pressure and this. So A by V square. What does it represent then? It represents pressure. So A by V square equals P. So A equals P V square. No, we just have to write the dimensions. P square, sorry, P. What is P? P is the pressure. Pressure is force upon area. As we know, pressure is force upon area. Unit of force. What are the unit of force? Is, as we have already discussed, the unit of force that was M, M1, L1, T minus 2, and area is L square. So this will be basically M1, this goes minus L minus 1, T minus 2. So this will be the dimensions of pressure. Okay. So using this over here, and what will be V square? V square we have already discussed is L cube to the power square is L to the power 6. Sorry for that. So now let's write the value of this. What is P? P is M1 L1 T minus 2, and this is L6. V square is L6. We have discussed this just right now. L6, and this is M1 L1 T minus 2 pressure. Okay, so that A will be M1, that will be L to the power 5 T minus 2. So this is A. M1 L to the power 5 T minus 2. Now again, come back to the equation B. Now again, from the volume V we can subtract only the volume. Therefore B must be representing volume only. So B is what? B is what? Is volume, which is equals to L to the power 3 L cube, or writing the full form will be M0 L3 T0. This is how we calculate B. Okay, so now you got it. So let's take one more example. Okay, now write the dimensions of A and B in the relation. The relation is this: P equals B minus X square upon AT, where P is power. Here saying P is what? P is power. X is distance and T is time. And T is time. Again, x square, as you can see, x square is subtracted from b, from the equation. X square is subtracted from b, therefore the dimensions of b are of x square. So b, x square is what? Length. Sorry, x is length, x square is square. So that is L2. This is b. This is b. And we have to find the dimensions of both a and b. Okay. Now again this equation we can rewrite this equation as p equals, this is L square upon a t. Okay, so a will be L square by p into t. Okay, so just writing the dimensions of all, this is L square. Power is work done upon time. Okay, so writing the dimensions of power is m L square t minus 3, and this is t. Solving it, this becomes m to the power minus 1, this will be reciprocated, these and these two will get cancelled, this is L0 actually, this is t to the power minus 2, goes up, t to the power 2. So these are the dimensions of a. So next is the derivation of formula from this dimensional equation. Now using the same principle of homogeneity of dimensions, we can derive the formula of a physical quantity. The condition is that we should know the factors on which the physical quantities depend. Now, using the principle of homogeneity of dimension, equate the powers of MLT. Usually equate the powers on MLT on both sides of dimensional equation, just as we used to solve the equation, given equation. That is the three equations are obtained, you solve it, you find the values of ABC, you substitute the value of ABC, you get the formula. Now, let's take an example. Okay, so derive an expression for time period t. Now the time period t of a simple pendulum which may depends upon. So now we know the factors on which it depends: on the mass of the bob, the length of pendulum L, and the acceleration due to gravity G. So these are the quantities in which it depends. So let's start our solution. So now t actually depends upon, you write this directly opposite sign, the mass m, let it be to the power a, the length of the pendulum L, let it be to the power b, and the acceleration due to gravity G, let it be to the power c. Okay, where a, b, c are the dimensions. You know what are dimensions? Dimensions are the power to which the quantities are raised. So a, b, c are dimensions. Okay, now t is actually equals to k m a L b g to the power c. So k is just a constant to remove this proportionality sign. Now k again is a dimensionless constant of proportionality, and we know that our limitation, we cannot find the value of this. Writing the dimensions in terms on MLT on either side. Now we are writing in forms of MLT. This is time, so this is m0, L0, t1. Okay, k will be just k. This is mass, so m a. We know that this is length, so L b, and this is acceleration due to gravity, is basically acceleration, which is L t minus 2 c. So this can be written as m a, this is L, this will be b plus c, b plus c, and this is t minus 2c. Okay, now applying the principle of homogeneity of dimension, compare it. So see, what is a? A is actually 0. L, comparing the power of L, what is b plus c? Equals 0. Comparing the power of t, minus 2c equals 1. So here we can calculate the value of c, which is minus 1 by 2. Okay. Now c is minus 1 by 2. What will be b? b plus of minus 1 by 2 equals 0. So b equals 1 by 2. And a remains to be 0. Now substituting these values in this equation. So t equals k, m 0, l is 1 by 2 and c is minus 1 by 2. So m0 means 1, this is under root l and this is 1 upon root c to the power minus 1 by 2. Sorry, g, this is g, I'm very sorry, this is g. C is minus 1 by 2, so root l upon root g. So t is equals k under root of l by g. Now as we know, we cannot find the value of k, but we can assume that by using other methods, we calculate the value of constant k as 2 pi. So this is the limitation, this is the limitation of dimensionless constant. So t is 2 pi under root l by g. Okay, we can take one more example. The force F acting on a particle moving uniformly in a circle. Now this is the force F acting on a particle moving uniformly in a circle depends upon the mass m, velocity v and the radius r of the circle. Derive the formula for that force. Okay, so the directly writing on what quantities it actually depends is F is what? F is equals to, writing the k first, so that's fine. K is the dimensionless constant, m mass, let it to the power a, velocity v to the power b and radius r to the power c. As you know, k is what? K is the dimensionless constant of proportionality. A, b, c are the dimensions or the powers of m, v, r respectively to represent f. Now our next step is to write the dimensional equation. So dimensional equation, this is force. Force we know, this is m1, l1, t minus 2. This is force. K, we cannot write for k. M is mass, so just write m power a. V is the velocity, lt minus 1. Velocity is lt minus 1 to the power b. R is the length, lc. Okay, solving this. This is m to the power a. This is l to the power b plus c. And this is t to the power minus b. Comparing with this, what is a? A is 1. B plus c is 1. And minus b equals minus 2. This implies what is b? B equals 2. Substitute in this. B is 2, c is 1. 2 plus c is 1. C is 1 minus 2. C is minus 1. A is 1, c is minus 1, b is 2. Now, substituting all the values in this formula, f is k, m to the power a, b to the power b, r to the power c. So f is equals k, so this is m 1 v square r to the power minus 1. So f is equals to k, so this is m v square by r. This is the required relation. Okay, now again I want to say something is that there are some limitation of dimension analysis. The derivation of formula by the method of dimensions, we come across various problems. Some of them I am telling you, which we have already discussed, is the dimensionless constant. So this method gives us no information about the dimensionless constant. For example, pi, small e. That gives no information about pi, small e, 1, 2, 3, anything. It does give no information about this. Now, if suppose the quantity depends on more than 3 factors having dimension, the formula cannot be derived. This is because the equation, we are using the 3 equation, MLT to the power that ABC on either side of dimensional equation. We can obtain only 3 equations from the 3 formulas. So there should be only 3 unknown dimensions of ABC. So if a quantity depends on more than 3, we cannot derive. Now also if the formula contains trigonometric function, exponential, log, they have no dimensions. Also we cannot determine the exact relation because again this thing, dimensionless constant. And it gives no information whether the physical quantity is a scalar or a vector.